Adult Solutions. Add-on desired.
Hello students, hope you are doing great. Welcome to Adult Solutions. I am Chandrakant, chemistry facilitator. We have started one another lesson, a periodic table. As you know that in the chemistry learning, atomic structure and a periodic table and properties, chemical bonding, these three are the pillars to grow to learning to continue better in the total chemistry. These three lessons are very important. So here we are, that is periodic classification. Everything, the classification is very important to better study, better organize, to know better about the elements, right? Let's start the questions with content together parallelly. Let us go. Well, the law of triad, Dobereiner's triad system. Who has done that? Dobereiner's, correct? Triad system. What is that triad system actually? Just take a recap about it. He has grouped the elements as three elements as a set. Three elements as a set, and they are similar in properties. What is the basis to make them as a set of three elements? Set of three elements. What is the basis? Average atomic mass. First element, third element, sum of the mass by 2 is equal to the middle element atomic mass. That's what the average. Average of 1 and 3 will be the atomic mass of the middle element. Okay, that is the principle taken by the Dobereiner, but that's not successful. Many elements are deviated. Dobereiner triad is given by the Dobereiner's. G, O, D are the correct symbols of right elements of the periodic table arranged in the increasing order of their atomic weights. Suppose some elements, capital G, O, D, some elements symbols there, and they arranged in the increasing atomic weights order. Then the atomic weight of G is 40 and D is 137. Okay, G is 40 and D will be 137. If GOD are the elements of Dobereiner triad, then find the atomic weight of O according to the Dobereiner. That is 40 plus 137 by 2 will be the answer. It is a hypothetical question. There is no element with capital G and O and D, right? But the focus on just a principle, that is 88.5. Okay, which of the following is not a Dobereiner triad? Not a Dobereiner triad. This is what the memory point is, a memory point only, where we have studied Dobereiner triads. Chlorine, bromine, iodine triad, because the masses are matching and they are set of similar properties. Set of similar properties and set of similar properties, atomic masses also matching. But here, iron, cobalt, nickel, that's not average. They are almost very similar in atomic masses. 1 unit here and there, similar in atomic masses. They are not average atomic mass concept. Iron atomic mass plus nickel atomic mass, average, never be equal to the cobalt. That's why Dobereiner's triad has failed. It's not the Dobereiner triad. The law of triads is applicable to, the law of triad applicable to metal, beryllium is keen, so that's not. Beryllium and boron, wrong. Fluorine, chlorine, bromine. Fluorine is not. Sodium, potassium, rubidium is not. Okay, so chlorine, bromine, iodine, this is the answer. The triad is applicable to the chlorine, bromine, iodine. Chlorine 35.5 and iodine is 127. Average of that very close to 80. Very close to 80, it is accepted. Option C is the Dobereiner triad. Well, statement, true or false related statement. We need to choose the right statement. Classification of elements is not useful to reveal the relationship between different elements. Is it the right statement? See, classification is to give the relation what kind of trend it is. That's wrong. One can give the relation. Option A is a wrong statement. Okay, that is wrong statement. Classification of elements may lead to correlate properties of the elements with some fundamental property that is a characteristic of the all elements. Is it? Yes, of course, that is a fundamental observation in the table. Classification of elements may lead to correlate properties, correct? That's what the aim, correlating the property. Then the answer will be B correct and A is incorrect statement. Elements with both a metallic and non-metallic characters are called. Elements with both a metallic and non-metallic characters are called. That is what a metalloid, like silicon, germanium kind of elements are metalloids. Arrangement of elements into groups of 3 is called as triad, correct? So option D. The statement meaning we need to know. Select the following pair of elements in which their arithmetic mean of atomic weight is equal to the atomic weight of the strontium. Which set it is? That means indirectly they are asking to select Dobereiner triad. Calcium, barium, middle, strontium will come, right? Calcium, barium, this is a Dobereiner triad, it is accepted. Sodium and barium, no. Sodium one group and barium another group. Sodium and calcium, different groups. Lithium and barium, different groups. But calcium, strontium, barium in one group and they are triads, Dobereiner triad. Arithmetic mean concept applicable to that triad system. Which of the following is a wrong triad? Carbon, nitrogen, oxygen is not a triad. Chlorine, bromine, iodine, lithium, sodium, potassium, calcium, strontium, barium are the Dobereiner triads. There is average atomic mass concept is valid and they are similar properties. Carbon, nitrogen, oxygen, atomic mass concept not valid and the properties also not similar. They are different properties. Okay. Which of the following is an achievement of the triad classification? One achievement is that relation between all properties of the elements. Whatever he has given a set, the properties are absolutely similar. Very good trend identified up to the successful triad systems. Iron, cobalt, nickel or some other elements has failed, okay, but wherever it is explained, that was wonderful. All properties in a regular trend. That's what the achievement. Okay, but the drawback is that all elements unable to organize as a triad system. Option A is the right answer. According to Dobereiner's law of triads, the dash elements arranged in the order of their dash in groups of 3 elements, that is physically similar atomic weights. First one, physically similar and atomic weights. No. Chemically different and atomic mass, no. Physically different or no. Option D. Chemically similar and atomic weights order it is. Based on atomic weights, that is grouping. Option fourth one. What was the number of elements in each set into which Dobereiner classified? In each set there are 3 elements according to the Dobereiner, correct? Dobereiner's law is rejected due to it is fundamentally not covering all elements and there is a discrepancy, some elements are not successful. Quite large number of elements cannot be grouped into triads, that's one reason. Yes, all elements not grouped into the triads. It was possible to group quite dissimilar elements into triad system, that's one another drawback, right? So both are the correct statements only. The elements which are no similar property can be grouped based on the principle A element and the C element. They don't have any similar in properties. A, C, take the average, we have the B element, but this A, B, C elements not in similar properties. Principle valid, but properties are not valid. Okay, so the statement A and statement B both are correct. Because of that reason, Dobereiner was rejected. The dash was the basis of the classification proposed by the Dobereiner and Newlands and Mendeleev concept. Atomic weight or atomic masses are the responsible. Atomic weight or atomic masses we use as a synonyms. There is a minor variation is there. Atomic weights and atomic masses in the chemistry we use as a synonyms. Both will be the answers. After that, they have some failures when the atomic number property was identified by the mostly modern periodic table built on atomic number and electronic configuration by the Niels Bohr. The law of octaves was proposed by Newlands. Newlands has suggested law of octaves, that was he has compared with the musical notes sa, re, ga, ma, pa, da, ni, and again the eighth letter will be sa, right? Saptaswara they have compared. Newlands at the time of with the Indian musical system, he has used that framing. The eighth element, first element and the eighth element will have the similar properties. If suppose the first element is the lithium, eighth element will be, at the time zero group elements are not discovered. Suppose take the lithium as 1, assume that lithium, after that beryllium, magnesium, calcium, strontium, barium, like this lithium, right? Okay, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. There is no neon at the time. Then after sodium, then the first element will be the lithium, eighth element will be the sodium, similar properties. But this principle, similarly you take about beryllium and magnesium, give 1 to the beryllium, magnesium will be the eighth element. Okay, so up to calcium this principle is valid. Law of octaves, first element and the eighth element similar in properties. But this is also rejected because of many elements not covered, and it is only successful up to calcium. Above calcium, no validity like that. The discovery of which of the following group of elements gave a death blow to the Newlands octaves? Which elements discovery? Yes, inert gases. When the inert gases are discovered, now the sodium is not the eighth element, sodium will be the ninth element. He said first element and eighth element will be similar properties, but now when the neon is discovered, all the zero group elements are discovered, sodium will be the ninth element, magnesium will be the ninth element to the beryllium, as has ruled out. Newlands concept, octaves concept has ruled out due to inert gases discovery. The most significant contribution towards the development of periodic table was made by most significant work. Many elements has covered and many elements organized in an order, and much more properties of an element has covered, like valency, oxidation state, melting point, boiling points. Many properties has given accountability. Many properties came into the trend, either decreasing order or increasing order. There is a trend given to the elements by organizing them in an order. That the work better given by Mendeleev. Okay, but still there are some drawbacks. Mendeleev has done the job. The number of elements known at the time when Mendeleev arranged them in the periodic table, that is 63. In his time, 63 elements are available. All the 63 elements he has organized, and it is astonishing to hear this. He has foreseen that the elements which are not discovered given blank space in his table. Mendeleev, in his periodic table, he kept some blank space so that there are some elements yet to be discovered. In his time, elements are not there, but definitely he has a strong belief that there are some elements in the nature. Then if you discovered, then keep it here, like that. Okay, so in his time 63 elements are available, all are organized. The horizontal rows and the vertical columns of a periodic table are called as periods and groups. The horizontal rows or series are called as periods. The vertical columns we call it as groups in the periodic table. Mendeleev Periodic Law, based on what is Mendeleev Periodic Law? Physical and chemical properties are the periodic functions of their atomic weights. That means if the elements arranged in the atomic weights increasing order or decreasing order, their properties will be in the periodic trend, that is continuously decreasing or continuously increasing and again repeating. That pattern is there. Physical and chemical properties are the periodic functions of their atomic weights. This is Mendeleev periodic law, that is based on atomic weights of the respective elements. Which one of the following is incorrect statement in respect of Mendeleev periodic table? That is, it has made the study of elements easier and systematic. No, that's not incorrect. It has helped in correcting the doubtful atomic weights. Incorrect statement. Which of the following is incorrect statement in respect of Mendeleev periodic table? Which is the wrong statement they are asking? It has paved the way for the discovery of the new elements. All the above statements are correct. It has helped in correcting the doubtful atomic weights. Yes, some elements atomic weights are correct. It is rectified. It has made the study of elements easier and systematic. Some extent. Well, so all statements are correct only. So let us, no disturbance in the question itself. There is no disturbance. This is also the right only. It has helped in correcting, some elements has rectified, atomic masses of some elements has corrected with the help of their valency. So it has made the study, all the statements are correct. So let's change the question itself wrong. Incorrect is no, all are right statements only. Okay, so all are correct. Answer D, all the above statements are correct, no disturbance in the question. So just a minor error, so rectify that. The two places left empty, by Mendeleev in the periodic table were gallium and germanium. Gallium and germanium has left spaces in the time of Mendeleev. These elements are not there, but he given spaces for these elements. They are gallium, germanium and scandium. Correct? Here the two elements, scandium is not in option, so we will go with gallium and germanium. Gallium was named by Mendeleev. Gallium was named by Mendeleev, that is Eka aluminum, Eka silicon, Eka germanium, right? Eka aluminum, Eka means in the Sanskrit that is one. In front of aluminum there is a space. He left, that is for the gallium purpose. He know there is an element in the nature which has to be kept in front of aluminum. Okay, so Eka silicon and Eka germanium, like that also. So gallium was called by Mendeleev as a Eka aluminum. Which element was named Eka silicon at the time of Mendeleev? That is germanium. Okay, Eka aluminum is the gallium and this is Eka silicon germanium. The element cited as example to prove the validity of Mendeleev's periodic law is, Mendeleev periodic law is absolutely correct because he given some spaces for the elements which are not discovered. After several years, those elements are discovered and those elements are kept in that places, so there is a periodic trend. Awesome, right? The foresight of the Mendeleev. The foresight of Mendeleev it is. Germanium, gallium, scandium discovery has a strong support to the Mendeleev periodic law is absolutely excellent, right? So all elements discovery will support Mendeleev periodic law. Now there are some elements as given: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Neon is not there, sodium. About table is related to Mendeleev and Newlands and Dobrinus and Moseley. above table is related to which one? First element and eighth element, that is related to new land. At the time, 0 group elements are not discovered. First element and eighth element are similar in properties. 1, 2, 3, 4, 5, 6, 7 and 8th element, correct? So that was the suggestion by the Newland's Octaves law. The number of elements in a period 1 of the periodic table, hydrogen and helium. Just 2 elements are there in the periodic table of the first period. First period is the shortest period. Only 2 elements existed. Dash as the fundamental properties of elements was recognized for the first time by Newland. The fundamental property that was first time observed, that is a periodicity. Periodicity, a property you take that is repeated in a regular interval. A property which will repeat in a regular interval is called as periodic property. You take atomic radius, left to right decrease, up to 0 group elements, up to 7th group elements atomic radius decreases, and then again increase starts, again decrease, increase. That's what the periodic trend. A property which will give a regular trend in a definite interval is called periodic trend. Okay, periodic property, that is called a periodicity.
Add-on solutions. Add-on desired.